Students, is it audible?
Yes, sir.
Yeah. So right now we have 5 participants. Let me wait for another 2 minutes and we'll start. So are the slides visible?
Yes, sir.
Yeah. So regarding last class, we were dealing with the module 1. So module 1, we had seen different classes of operating system. So what are those? So we have basically 5 different classes of operating system according to your prescribed textbook. So can you name those 5 types of classes of operating system? Can anybody name them? So we have a batch processing operating system. So we have multi-programming operating system. So then time sharing operating system, then real-time operating system, and last one was a distributed operating system. So in the last class, we were discussing the distributed operating system, where we have many terminals, many computers, many systems have been connected through a network. So for the purpose of sharing their job, say task or programs. So we have a network basically, and for this particular network, all the systems have been connected so that the system can share the task between the other systems. Okay, and if one system is having a particular software or any resource, so then that particular resource present in one computer or one system can be shared with the other systems as well. Why? Because all these systems, all these computers have been connected through a network. Okay, and if say any one node or any one computer is overloaded with more number of programs, more number of processes, means those processes can be shared among other systems as well. Okay, so we have seen the distributed operating system, and we can compare this with the centralized operating system. An example for centralized operating system is a Google server, and to fulfill the request of users, the Google server should run all the time. Means 24/7, the Google server should be busy. Okay, so when compared to this centralized server, so-called Google server, here in case of distributed operating system, what we have is I can have more number of servers. Okay, so if one server fails, means I can take the help of other server. Means say if like say if one server is going down or going slow, means I can request another server to help me out. Okay, and that is the main purpose of this distributed operating system. Uh, yeah, and we also see the benefits of distributed operating system. So where resource sharing is the main concern, main prime concern in case of distributed operating system is to have the effective resource sharing, and as well as reliability and computational speed up and communication. Like all these factors, like we have seen in the last slide. And regarding today's class, so start with the key concepts or and techniques used in distributed operating system. So we have basically a small table given here. So where we have a concept and technique used and explanation of those concepts. So the first is distributed control. So what do you mean by the word distributed control with respect to distributed operating system? So what we can say is, suppose if I take a centralized operating system, and we know that there in case of centralized operating system, every operation what we perform. So for example, say allocation of resources maybe, or say running of a process, or say the communication between the different computer systems, all these tasks, right, are to be carried out through the internet that has been connected. And also we saw that the main disadvantage in case of centralized operating system or in case of centralized server, so the main disadvantage, the main demerit was if the server or the centralized server fails, or if the centralized server goes slow or goes down, so then the entire communication network will be halted. So, but in case of this distributed control, so what we see is all the resources will be distributed throughout the network. Okay, and when user requests for certain resource, and if say one computer fails to allocate or execute that particular resource, or say if one computer fails to allocate a particular resource to the user, so then other computer system can allocate the resource for the particular user. Okay, hence we have all the resources will be distributed in case of a distributed operating system. Hence, a control function is done through the participation of several nodes. So here, several or say almost all the nodes will be participating in the distributed control system. Okay, and we don't have a centralized server as such. Okay, so we don't find a centralized system as such, wherein if the centralized server fails, means the whole network will be halted. Okay, so but in case of a distributed operating system, directly one system can communicate with the other system, right? Because all systems are being connected through the internet. So regarding the concept called as transparency, so like explanation for this is, say a resource or service can be accessed without having to know its exact location in the distributed system. Means a resource or service can be accessed without having to know the exact location in the distributed system. Say, for example, one sitting in India can access the user or the resource sitting in, say, other countries, for example. And say if main branch of SBI, like in banking system, like if I take the example of this, so the concept of transparency in case of banking system means one, say SBI branch, SBI main branch can access or can share files or can communicate with other branch, say for example, other branch in Gujarat, okay, very easily. Why? Because all the computers are being connected through the internet. Hence, we have higher transparency. And regarding the concept called as remote procedure call, we call it as RPC. RPC stands for remote procedure call. So a process calls a procedure that is located in a different computer system. I repeat, a process calls a procedure that is located in a different computer system. And this remote procedure call, so-called RPC, is analogous to a procedure or function call in a programming language. So what we normally go for the calling of procedures or functions in the programming language. Okay, exactly similar to this, like we have something called as a RPC. Okay, so what is the example for this? If I take, say for example, like if you're reading a book, say for example, like you'll be reading a book in your room, and your father comes and tells you to go to the bank and open an account in the bank. So like in that situation, what you'll do is you will not be reading the book. Instead, what you can do is you'll put a bookmark, like so as to indicate at which page you had stopped the reading, and you go to the bank and you'll open the account. Okay, exactly similar to this, you have something called as a remote procedure call. Okay, like here the procedure is the opening of account in the bank, and the bank is there in a remote place. Okay, so you need to go to the remote place, I mean the bank. You need to execute a procedure of opening an account. Okay, so this is exactly similar to the remote procedure call. And you again come back to your home and start reading the book from where you had left. Okay, same thing will be done in the operating system as well. Here the OS will pass some parameter, like say what operation should be done. Okay, and for that operation, so what all resource you need, etc. Okay, so we can explain this example for the remote procedure call. And in total, these are the three key concepts and techniques used in the distributed operating system. And for your reference, I have written the same explanation for each and every concept or technique here. Okay, so you can take the help of these explanations. Okay, so next is now dealing with the second class of operating system that we call it as multi-programming operating system. So the word multi itself indicates that you'll be having n number of programs, that you'll be having n number of processes or n number of programs in a single computer system. Okay, so by having many processes in the RAM and executing them, we can effectively use the CPU. So the here, so main aim of this multi-program operating system is to execute more number of programs, multiple number of programs, more number of processes in a single computer system. So by having n number of processes in the RAM or in the main memory and executing them. So let's have to keep the CPU busy all the time. So the main intention behind the development of this multi-programming operating system is to effectively go for a use of resource utilization, so as to use effectively all the resources of computer system. So this multi-programming operating system was developed. Okay, suppose if there is a system, suppose if the system is running only one program or only one process, so then it will use only limited amount of resources. Hence, like in this case, we'll be having the wastage of other resources. Means the other resources will not be properly utilized. Hence, what can be done is I can put or I can invite, right, more number of programs or more number of processes inside the RAM, so that CPU is always busy in executing one of the other processes, right? So for this particular concept, so you can have a simple example like this. A system has got the five 1 MB of memory. Okay, so we have 5 number of 1 MB of memory, and if user process is using only 1 MB of memory, okay, so out of 5 number of 1 MB of memory, the user is just using only 1 MB of memory, and the rest of 4 MB of memory is being wasted. So here I can bring 4 more processes so that I can effectively use the rest of 4 MB of memory. Hence, I can have the calling of multiple programs in the system, and the CPU can be always busy in executing one of the other programs. Okay, so the OS can handle multiple programs simultaneously. So this concept we call it as multi-programming operating system. Hence, the resources are also utilized effectively, means 100% resource utilization, so-called memory is being used here. So a multi-program operating system has many programs in memory of the system and at any time running simultaneously. Hence, the name is given as multi-programming operating system. And the main intention behind the development of this multi-programming operating system is effective resource utilization. And simple example is been rightly quoted here. Okay. Yeah. So the second main point in multi-programming operating system is this multi-programming OS will be using something called as a DMA mode of input and output operation. So the word DMA stands for direct memory access mode of input output operation. So it can perform IO operation of some program while using the CPU to execute some other program. So what the sentence means is, like we know that suppose if any process or any program is doing input and output operation, in that case CPU will be kept idle. Okay, why? Because CPU's main intention is to do the computations, right? And for the IO operation, we don't need any sort of computations. Hence, CPU will be idle while the process or a program is busy in performing input and output operation. So, like this programming, so this multi-programming operating system, like this will be using direct memory access mode of IO, and this has been indicated. So for your reference, like this particular figure, like where we have the direct interaction between the memory and the disk without the use of CPU, means the memory is being accessed, right? So we have interaction between memory and the hard disk, okay, directly without the involvement of the CPU, okay, and that we call it as direct memory access, okay. And the third point is, like in case of this multi-programming operating system, or in case of any OS as such, we come across 2 different types of programs, okay. So one we call it as CPU bound programs, and second type is IO bound programs. So before dealing with this CPU bound and IO bound programs, I want to, like, is it audible? Are you listening?
Yes, sir.
Yeah. So right now, like we are dealing with this multi-programming operating system, where we can have more number of programs, more number of processes to be stored in the memory, so that I can execute multiple number of programs inside a single computer system. And so this multi-programming OS will be using the concept called as a DMA mode of input and output operation. And the basic concept here is, always remember this, when any process or any program is doing IO operation, so then CPU becomes idle, and I can't expect a valuable resource, so-called CPU, to be idle. Okay, so for that reason, what I can do is I can invite some programs into the memory, and I can keep the CPU busy. Okay, and for that, this multi-programming OS will be using a technique called as DMA mode of input and output operation, where we have the direct interaction between the memory and the disk. Okay, directly without the involvement of CPU. Hence, the CPU can be used to execute some other programs. So I can avoid the CPU being idle. Okay, and with respect to this multi-programming OS, we come across two different types of programs. So one is CPU-bound programs, and the other one is IO-bound programs. So we have a small diagram also to indicate the so-called CPU-bound programs and IO-bound programs. So regarding the concept of this CPU-bound programs, like as name itself indicates, CPU-bound means the process or the programs are CPU-bound means we have more number of computations, more number of calculations in our program or in our process, and a small amount of IO operations. So when compared to the IO-bound programs, as here also the name itself indicates, IO-bound means all the programs, all the processes are IO-bound means such programs will be involving more amount of input and output operations and very less computations, very less calculations. So if the process or if our program or process is involving more amount of calculations and less amount of input and output operations, then those programs will come under CPU-bound programs. And if our programs or if our process is involving more amount of input and output operations and less amount of computations or calculations, right? So then those programs comes under IO-bound programs. Okay, same thing like I given here, and heading is the CPU-bound programs. If our program or process needs only CPU for its execution, and it does not need any IO operation, then we say the program is entirely CPU-bound program. Okay, similarly, same lines for IO-bound programs. Okay, IO-bound programs are here, IO operations are more. Okay, so here input and output operations are more when compared to the computational work. So when IO is done, so then CPU becomes idle. Hence, what we can do is CPU is assigned to some other processes. Okay, so it will use or it will employ DMA mode of input and output operation. Again, the word DMA is direct memory access. Okay, and for this particular so-called technique, the figure is this one. Suppose if I want to have the access of the disk, okay, hence we can have the access to this disk and the memory, means these two blocks can communicate directly without the use of CPU. So this multi-programming operating system will be using this DMA mode of IO operations. And with respect to programs, don't forget that these concepts, CPU-bound programs and IO-bound programs, will be coming in multi-programming operating system, where the definition for CPU-bound programs, as name itself indicates, CPU-bound processes, CPU-bound programs are nothing but in our process, we have more computations. See, a lot of computations are there in our process and a few number of IO operations. So those process will come, like those programs will be coming under CPU-bound programs. And when compared to the IO-bound programs, as name itself indicates, these IO-bound programs will have little computations, small amount of computations, small amount of calculations, but they involve more number of input and output operations. Okay, right. So next concept in this, like how the multi-programming OS will be handling different processes in a system. Okay, so the heading for this multi-programming operating system is how the multi-programming OS handles different processes inside a system. So for that you have these three diagrams. Okay, so you can take so this particular rectangular block as a cube. Okay, where we have this multi-programming kernel. So this is the same as the OS. Okay, it's a part of the operating system, and we're calling it as a multi-programming kernel. Why? Because here we are discussing the concept of multi-programming OS. Hence, this particular part of OS can be called as a multi-programming kernel. And you have here the different programs located. Okay, so we have here program 1 and program 2 and program 3, where program 1 is having IO operation. So this program 1 is now computing the IO operations. Okay, hence this program 1 is not in need of CPU. Hence the CPU can be allocated to the program 2. Hence currently the CPU is executing the program 2, and program 3 is idle. Means this program 3 is either waiting for CPU or IO operations. Okay, and if you come to the second program here, means again the program 1 is still doing the IO operation. So but this program 2 has started input and output operation. Like in the earlier figure, this program 2 was carrying out CPU. Means this the so-called program 2 was involving more amount of calculations, computations. Hence CPU is given to the program 2. So but now this program 2 is being switched to conduction of input and output operation. Hence the CPU is now allocated to program 3. Okay, like as you can see here, this CPU is always kept busy in executing either program 2 or program 3. Okay, so here as CPU, here as the program 2 is now busy in doing IO operation, hence the CPU can be allocated from program 2 to program 3. Now in second figure, now the CPU is executing program 3. And if you look at the third figure here, the program 3 has finished its execution. Okay, and if the program 1 has finished its IO, so then CPU is now assigned to the program 1, and program 2 is now still doing the IO operation. Like as you can see here, like in the previous figure also, the program 2 was doing IO operation, right? And in figure 3 also, still the program 2 is still doing the IO operation. So but program 3 has finished its work. Okay, hence the CPU is now allocated to the program 1. So what is the bottom line here is we have the switching of the programs from IO operations to the CPU operations. Okay, so the time so we have the effective switching between the IO operations and the CPU operations. So the time when process is doing IO operation, we know that CPU will not be doing anything, or the CPU will be kept idle. Hence, CPU is used to execute some other programs. So this arrangement makes the effective use of both the CPU as well as the input and output operations. So in case of multi-programming OS, we have an arrangement whereas the effective use of both CPU and IO operations is made. Okay, and using these three figures, you can effectively make use of CPU operations as well as the IO operations just by switching from IO to CPU as well as from CPU to IO operation. So next concept is the priority of programs. Okay, like as we know that we have so basically two kinds of programs in multi-programming OS, and those are CPU-bound programs and IO-bound programs. And we have a figure to indicate that always the IO-bound programs will be given highest priority when compared to the CPU-bound programs. Okay, so that explanation comes next. So, but for now, let me deal with the priority of programs. So the heading for this, let's call the priority of programs, it says that suppose if we have like any two processes, and these two processes are so like both the processes are willing to use the CPU. Okay, and that is not possible because at any set of time CPU is always executing only one process. Okay, so here suppose if I have any two processes that are fighting between themselves for the request of CPU, so this fighting is not valid. Okay, so we can stop the fighting of the two processes for a single resource, so-called CPU, just by assigning the priorities to the different processes. So this priority of programs is nothing but the select what do you call it as it's a tie between the two different processes. Okay, suppose if we have a tie between the two different processes, in that case, so this tie can be solved by allocating the priorities for the two processes. Okay, and a measure of the performance of a multi-programming OS is throughput, means the ratio of number of programs processed and the total amount of time taken to process them. Like if you remember, always the throughput will be something called as any entity, any parameter, any concept measured with respect to the time factor, that will be called as throughput. Okay, so same concept here also, the ratio of number of programs being processed and the total amount of time taken for the process, we call it as throughput, and this throughput is a measure of performance in case of a multi-programming operating system. Okay, like I repeat, here the heading is priority of programs. Again, the word priority of programs refers to the tie between any two different processes. Again, the word tie refers to, say if n number of processes or more than one number of processes are trying to use the same resource, then that is not possible. Hence, we'll be allocating the priorities for different processes, and based upon the priorities only, the resource will be allocated. So OS must keep a sufficient number of user programs in the memory. Why? Because CPU will not be executing only single program up to its finish line. Okay. Hence, we need to keep sufficient or more number of programs, user processes in the memory. So then multi-programming OS is said to be performing 100%. So like I cannot keep CPU always busy with only single program. Why? Because I need to give fair service to all the processes. Hence, what we should do is I should be able to maintain more number of user programs inside the memory. Hence, I can effectively make use of this multi-programming operating system. Okay, and if it is, if it does not have sufficient programs, then CPU has to wait until one or the other program is executed. Okay, and this we call it as degree of multi-programming. Remember this important concept. So what is degree of multi-programming? How much programs, how much user programs are being maintained in the memory? Okay, so that number we call it as degree of multi-programming. And what we expect usually is we should be able to have a higher degree of multi-programming. This means that I should be able to maintain more and more number of user programs inside the memory so as to increase the degree of multi-programming. So this uses overlap of CPU and IO activities in our programs. Suppose if I take any program, means any user program, okay, will be having an appropriate mix, okay, appropriate program mix of CPU programs as well as IO programs. Okay, like it uses an appropriate program mix so that some of the programs in the memory are CPU bound and other programs will be IO bound. So this statement says that in the memory you do have an appropriate program mix where some of the programs in memory will be of type CPU bound programs and the other type will be of IO bound programs. And of course, like I think we know the meaning of the CPU bound programs and IO bound programs. Okay, yeah. Like a simple example, like it's been given here. Suppose if I'm executing the program hello world, okay, and I want to print this hello world. Okay, so this particular statement is having some some CPU bound instructions as well as some IO bound. Okay, so this statement is partially I need a CPU for the execution of this particular statement. Why? Because the program will be always starting with the main. Like we know that every C program will be starting with the main, and this program is also using IO operation. Why? Because I have used printf. Okay, so for the execution of printf, like I'll be in need of IO operation. Why? Because I need to print this hello world on the computer screen. Okay, so when doing IO operation, the CPU will be released and allocated to some other process. Why? Because when we are doing IO operation, CPU becomes idle, and I can't expect this valuable resource. Okay, so that CPU will be always kept busy in executing some one or the other process. Hence, when any process is doing IO operation, then this CPU can be allocated to other process. Okay, so that I can keep this CPU always busy, right? And if you take any program, okay, any program in general will be having a mix of CPU bound programs and IO bound programs, and a part of the program will be executed on CPU. And when it requests for IO, okay, IO needs to be allocated to the process and execution has to be completed. Okay, so for this, so what OS will does is OS will be using priority based preemptive scheduling. Okay, so this means that always the CPU will be allocated, or the CPU will be scheduled for the process having the highest priority, so as to share the CPU among n number of programs to ensure good overlap of the CPU and IO bound activities. Okay. Yeah, like a simple example is being given here. Suppose if I have three processes P1, P2, and P3, where I'll be assigning this P1 as the lowest priority and P3 is assigned as highest priority. Okay, so this kernel assigns numeric priorities to the program. So this 1, 2, and 3 are nothing but the numericals, where this 1 refers to the lowest priority of process P1, and number 3 refers to the highest priority assigned to the process P3. So the kernel will be able to assign numeric priorities to the programs. We assume that these priorities assigned for these particular programs or processes are just a positive integers, and a larger value always implies higher priorities. Say for example, here 1, 2, 3 are the priorities assigned, or the positive integers assigned, where 3 is the largest integer. Hence, the process P3 will be having the highest priority. And after P3, so this 2 is the second highest. Hence, this P2 is the low priority, and the lowest priority among these processes for P1. Okay, so the kernel give CPU to the program always having the highest priority. Okay, and the kernel will be able to preempt. Again, the word preempt refers to the forceful release of the resource from the process. Okay, suppose you say, so this lowest priority P1 is being rightly executing by the CPU, and if say the third process comes into existence, okay, like in that case, the resource allocated to the P1 process will be preempted, will be forcefully removed, and those resources will be allocated to the highest priority, so-called P3 process. So this forceful release of the resource from a low priority process and assigning those resources to the higher priority process is called as preemption. Okay, don't forget this. So hardly we have a few minutes left. So next concept is in case of multi-programming environment, always IO bound programs will be given highest priority when compared to the CPU bound program. So this particular line of sentence is being justified using this particular timing chart. The way we have the program, that is IOB's program bound, IO bound programs, and program CB is the CPU bound programs. Okay, so by using these two timing charts, we are able to show that always the IO bound programs will be given the highest priority when compared to the CPU bound programs. And this, like I'll be discussing in the next class. And after this multi-programming OS, I'll be dealing with the like so-called time sharing operating system. Okay, so for this class, what we had discussed is regarding the distributed operating system and the key concept and techniques used in a distributed operating system. And basically those are distributed control and transparency and RPC. An example for remote procedure call is nothing but the opening of an account, okay, so asked by your father while you are reading a book. Like in that case, what you will simply do is you will keep a bookmark so that after you go for the opening of a bank account, and once you return from the bank, again you can start reading from the same page where we had left. Okay, so like this is analogous to a procedure function call, so what we normally use in the programming language. And individually, these techniques used in the so-called distributed operating system is being dealt individually, and here are the explanations. And next we dealt with the multi-programming operating system, where the main intention is to have effective resource utilization. Along with the example is being rightly quoted here, along with the technique used in multi-programming OS, that is DMA, mode of IO operation. Again, we have two kinds of programs, CPU-bound programs and IO-bound programs, along with their meaning and how the multi-programming OS handles different different processes in a system. Okay, so this particular concept is been explained using these three figures. So where we have the switching between IO operations and the CPU operations. And regarding the priority of programs, like so these concepts can be asked in the examination. Explain the concept of priority of program with respect to multi-programming operating system. Okay, like here we come across one so-called definition called as degree of multi-programming. So based upon the number of user programs that are being maintained in the memory, so we can call that as a degree of multi-programming. Okay, and we have a appropriate program mix of IO-bound programs and CPU-bound programs, right, in the programs which are present in the memory. Okay, and next concept in the next class, and what I'll be dealing is always the IO-bound programs will be given highest priority when compared to the CPU-bound programs. Okay, so for now we can log out. Okay, so we can log out from now, and let me discuss for the remaining concept in the next class. Right? Thank you.